Today, what we're going to take a look at is we're going to go ahead and look at Chapter 10, which is dealing with management control by explaining how standard costs are used by managers to control costs. Also, how to compute direct materials, direct labor, and our variable overhead variances. So standard costs, setting the stage. So just some basic definitions and concepts. A standard is a benchmark for measuring performance. In managerial accounting, two types of standards are commonly used by manufacturing, service, food, and not-for-profit organizations. Price standards specify how much should be paid for each unit of input. For example, hospitals have standard costs for food, laundry, and other items. Home construction companies have standard labor costs that they apply to subcontractors such as framers, roofers, and electricians. Manufacturing companies often have highly developed standard costing systems that establish quantity and price standards for each separate product's material, labor, and overhead inputs. And then quantity standards would specify how much of an input should be used to make a product or to provide a service. So auto centers like Firestone and Sears set labor time standards for the completion of work tasks. So they're saying, within to do a certain job, let's say on someone's car to complete a certain job, they're going to say, it should take X amount of time to do that. Fast food outlets such as McDonald's have exacting standards for the quantity of meat going into a sandwich. So they're going to say, you have to use, so much. All right. So setting the direct material standard. Now, the standard price per unit for direct materials should reflect the final delivered cost of the materials. The standard quantity per unit for direct materials should reflect the amount of material required for each unit of finished product, as well as an allowance for unavoidable waste, spoilage, and other natural inefficiencies. Setting direct labor standards. The standard rate per hour for direct labor includes not only wages earned, but also fringe benefits and other labor costs. Many companies prepare a single rate for all employees within a department that reflects the mix of wage rates earned. The standard hours per unit reflects the labor hours that are required to complete one unit of product. Standards can be determined by using available references that estimate the time needed to perform a given task, or by relying on time and motion studies. Setting variable manufacturing overhead standards. The price standard for variable manufacturing overhead comes from the variable portion of the predetermined overhead rate. The quantity standard for variable manufacturing overhead is expressed in either direct labor hours or machine hours, depending on which is used as the allocation base in the predetermined overhead rate. The standard cost card. The standard cost card is a detailed listing of the standard amounts of direct materials, direct labor, and variable overhead inputs that should go into a unit of product, multiplied by the standard price or rate at which that has been set for each input. Okay. So using standards and flexible budgets, activity and spending variances. Standard costs per unit for direct materials, direct labor, and variable manufacturing overhead can be used to compute activity and spending variances as described we looked at in the previous chapter. Price and quantity variances. Spending variances become more useful by breaking them down into price and quantity variances. And this is our focus in this chapter. A general model for standard cost variance analysis. Price and quantity variances. So a price variance is going to be the difference between the actual price of an input and its standard price, which is multiplied by the actual amount of the input purchased. A quantity variance is the difference between how much of an input was actually used and how much should have been used at the actual level of output, and is stated in dollar terms using the standard price of the input. Price and quantity standards. Price and quantity standards are determined separately because price and quantity variances usually have different causes. In addition, different managers are usually responsible for buying and for using inputs. For example, the purchasing manager is responsible for raw material purchase prices, and the production manager is responsible for the quantity of raw materials that are used. The buying and using activity occur at different points in time. For example, raw material purchases may be held in inventory for a period of time before being used in production. So the general model and overview. Price and quantity variances can be computed for all three variable cost elements: direct materials, direct labor, and the variable manufacturing overhead, even though the variances have different names as shown. Although price and quantity variances are known by different names, they are computed exactly the same way as shown on this slide. For direct material, direct labor, and variable manufacturing overhead. The actual quantity represents the actual amount of direct material, direct labor, or variable manufacturing overhead use. And again, we're talking about quantities that are dealing with the inputs, so whatever we're using to make the product or to deliver the service. So in the case of direct materials, the quantities will be stated in terms such as pounds, ounces, and not in a number of units of finished product. So it's in what actually goes into the product. The standard quantity represents the standard quantity allowed for the actual output of the period. And then again, remember that the SQ portion of the model is the most common stumbling block for students when it comes to variance analysis. And so SQ refers to the standard quantity of inputs allowed for the actual level of output achieved. For example, if 5,000 drapes were produced and each drape required 2 yards of fabric, the standard quantity allowed would be 10,000 yards. Any other amount of fabric used would result in a variance, either too little or too much. The actual price represents the actual amount paid for the input used. The standard price represents the amount that should have been paid for the input. And now using costs, direct materials, and direct material variances. So we're going to take a look at this and kind of go through an example. So this is for Glacier Peak Outfitters. So the material price variance defined as the difference between what is paid for the quantity of materials and what should have been paid according to the standard is $21 favorable. The price variance is labeled favorable because the actual price was less than the standard price by 10 cents per kilogram. So $5 per kilogram minus $4.90 per kilogram. The material quantity variance described as the difference between the quantity of material used in production and the quantity that should have been used according to the standard is $50 unfavorable. The quantity variance is labeled unfavorable because the actual quantity exceeds the standard quantity allowed by 10 kilograms. So 210 kilograms minus 200 kilograms. Now, again, remember that a favorable price variance might not always be a good thing. If it arose from receiving inferior or obsolete goods at a reduced price, the total cost for making the company's products might be higher, right? Because if it's inferior, we're going to have to use more of it, or we're going to have to, our finished product's not going to come out the way that it's supposed to, or if it is obsolete, then again, it's not going to come out the way that it's supposed to. All right. So supporting an additional computation. So the standard quantity of 200 kilograms was computed as shown. And so we see that. So we know that per each parka, we're using 0.1/10 of a kilogram times 2,000 parkas is 200 kilograms. Now, the actual price of $4.90 per kilogram was computed as follows. So you have the amount that was spent divided by the number of kilograms that was used. That'll get you how much per kilogram. And then the equations that we have been using thus far can be factored as shown and used to compute price and quantity variances. Okay, direct materials variances, points of clarification. The purchasing manager and production manager are usually held responsible for the material price variance and the materials quantity variance, respectively. The standard price is used to compute the quantity variance so that the production manager is not held responsible for the performance of the purchasing manager. The materials variance is not always entirely controllable by one person or department. For example, the production manager may schedule production in such a way that it requires express delivery of raw materials, resulting in an unfavorable material price variance. Because if we need it express delivery, then those materials might cost more than what they otherwise would. The purchasing manager may purchase lower quality raw materials, resulting in an unfavorable material quantity variance for the production manager. So that's how that relates. Let's do a quick check. So Hansen Inc. has the following direct material standard to manufacture one zippy. So 1.5 pounds per zippy at $4 per pound. Last week, 1,700 pounds of material were purchased and used to make 1,000 zippies. The materials cost a total of 6,630. So first of all, how many pounds of material should Hansen have used to make 1,000 zippies? Right? It should have been 1,500 pounds because we made 1,000 zippies times 1.5 pounds. Should have been 1,500. And then the material quantity variance for the week was, what was it? It was $800 unfavorable because we took the $4 and then we multiplied by the difference of 1,700 by minus 1,500 to get us how much more material was used. So if we multiply that, we come out with 800 unfavorable. Now, Hansen's materials price variance, or MPV, for the week was 170 because we have 1,700 pounds that we bought times $3.90, subtract $4. So we paid $3.90 a pound. So it was 10 cents a pound. So we multiply that, we come out to $170 favorable. All right. And then we see here worked out how another way that we could work that out. So this Okay. Now, the next section is again continued, and we're going to assume the information that we see here. So we see that Glacier Peak Outfitters has the following, and this is to figure out for labor variance, has the following direct labor standard for its mountain parka. So we use 1.2 centered hours per parka at $10 an hour. Last month, employees actually worked 2,500 hours at a total labor cost of $26,250 in order to make the 2,000 parkas. And so what we can do then is figure out what our labor rate variance is and what our labor efficiency variance was. So our labor rate variance is defined as the difference between the actual average hourly wage and the standard hourly wage is going to be 1,250. That's unfavorable. And the rate variance is labeled unfavorable because the total average wage rate was more than the standard wage rate by 50 cents per hour. So it'd be $10.50 an hour minus $10 an hour. And then the labor efficiency variance is defined as the difference between the actual quantity of labor hours and the quantity that was allowed based on the standard is $1,000 unfavorable. And the efficiency variance is labeled unfavorable because the actual quantity of hours exceeds the standard quantity allowed by 100 hours. So 2,500 hours subtracted by 2,400 hours is 100 extra hours. And then some supporting additional computations. So the standard quantity of 2,400 hours was computed as follows. So 1.2 hours per parka multiplied by 2,000 units gets you 2,400 hours. And the actual price or rate of $10.50 was computed as shown. So 2,625 divided by 2,500 hours, which is the number of hours that they used, gets us $10.50 an hour. And then factored equations can also be used in order to compute the efficiency and rate variances. Okay, so direct labor variances, points of clarification. Labor variances are partially controlled by employees within a production department. For example, production managers, supervisors can influence the development of highly skilled workers and less skilled workers on tasks consistent with their skill level. Deployment, so having more skilled workers work in areas where that's needed, and then workers that don't quite have those skills in areas that are more easy for them. The level of employee motivation within the department, managers can affect that. The quality of the production supervision and the quality of the training that was provided to employees. However, labor variances are not entirely controlled by one person or department. So, for example, the maintenance department may do a poor job of maintaining production equipment. This may increase the processing time required per unit, therefore causing an unfavorable labor efficiency variance. And the purchasing department may purchase lower quality raw materials, resulting in an unfavorable labor efficiency variance for the production manager. So we'll do another quick check. So Hansen Inc. has the following direct labor standard variance standard to manufacture one Zippy. So we have 1.5 centered hours per Zippy at $12 per direct labor hour. Last week, 1,550 direct labor hours were worked at a total labor cost of $18,910 to make 1,000 Zippies. So what is the direct labor variance for the week? And it's going to be 310 because you have 1,500 hours, and then you have $12.20 minus 12, so 20 cents. So 1550 times 20 cents is 310, and that's unfavorable. Because it was actually, our rate was higher than what it should have been. And then the labor efficiency variance for the week is going to be $600 unfavorable, because you have $12, and then you have, which is the amount, the standard, and then we used 1,550 hours, and we should have only used 1,500 hours. So we used 50 more hours than we should have, times $12 an hour, comes out with $600. And you can work it out that way as well. All right, so now looking at the variable manufacturing overhead rate and the efficiency variance, and explain their significance. So we'll look again at another example. So so again, Glacier Peak Outfitters uses direct labor hours as an allocation base in its predetermined overhead rate. The company has the following standard variable manufacturing overhead cost for each mountain parka. So they would use 1.2 standard labor hours per parka at $4 per direct per labor hour, and that's how they figured, that's what their predetermined overhead rate is. So last month, employees worked 2,500 labor hours to make 2,000 parkas. The actual variable manufacturing overhead for the month was 10,500. So the variable overhead rate variance is defined as the difference between the actual variable overhead costs incurred during the period and the standard cost that should have been incurred based on the actual activity for the period. And in this example is $500 that's unfavorable. The rate variance is labeled unfavorable because the actual variable overhead rate was more than the standard variable overhead rate by 20 cents per labor hour. So $4.20 minus $4. That's how that's calculated. The variable overhead efficiency variance, defined as the difference between the actual activity of the period and the standard activity allowed multiplied by the variable part of the predetermined overhead rate. It's $400, which is unfavorable. So the amount that was spent is more than what the amount that should have been. And then the efficiency variance is labeled as unfavorable because the actual quantity of the activity, which is labor hours, exceeds the standard quantity of labor hours by 100 labor hours, 2,500 hours instead of 2,400 hours. And some supporting and additional computations. The standard quantity of 2,400 labor hours is computed as shown. So we use 1.2 hours per parka times 200 parkas. Should have been 2,400 hours that we would use. The actual price of $4.20 is computed as shown. So you have 10,500 divided by 2,500 direct labor hours, which is what they used, gives us $4.20 an hour. And then you can use factored equations, can also be used in order to calculate the efficiency and rate variances. So another quick check. Hansen Inc. has the following variable manufacturing overhead standard to manufacture one zippy. So 1.5 standard labor hours per zippy at $3 per direct labor hour. Last week, 1,550 direct labor hours were used to make 1,000 zippies, and 5,115 was spent for variable manufacturing overhead. And so Hansen's rate variance for the variable manufacturing overhead for the week would have been $465 unfavorable. So you're going to take the 1,550 hours that they used, multiply that by 3.30 minus $3, or 30 cents. So 30 cents times 1,550 is going to be 460, and that's unfavorable. And then their efficiency variance for the variable manufacturing overhead is going to be $150 unfavorable. And so in order to calculate that, you're going to have $3 times 1550 minus 1500, or 50 units. So 50 times $3 is 150. And then we see here worked out how that would be. Now, material variance is an important subtlety. When the quantity of materials purchased differs from the quantity used in production, the price variance is based on the quantity purchased, and the quantity variance would be based on the amount that was used in production. So we'll see here kind of how that would work out. So Glacier Peak Outfitters has the following direct material standard for the fiber fill in its mountain parkas. So 0.1 kilograms of fiber fill per parka at $5 per kilogram. And last month, they had 210 kilograms of fiber fill were purchased at a cost of $1,029. Glacier used 200 kilograms to make 2,000 parkas. And so the material price variance would be computed using the actual quantity that was purchased, which is 210 kilograms. Therefore, the material price variance is $21 favorable. And then the material quantity variance is going to be computed using the actual quantity that was used in production, which is 200 kilograms. And that's what it calls for. So we had no variance in direct material quantity. Now, standard costs, managerial implications. The advantages of standard costs. Standard costs are a key element of the management by exception approach. Standards can provide benchmarks that promote economy and efficiency. Standards can greatly simplify bookkeeping, and standards can support responsible accounting systems. But some potential problems with standard costs are that standard cost variance reports are usually prepared on a monthly basis. Hence, they may contain information that is outdated. If variances are misused as a club to negatively reinforce employees, morale may suffer and employees may make dysfunctional decisions. Labor variances make two important assumptions. The first is that they assume that production is labor-based or labor-paced. If labor works faster, output would go up. Second, they assume that labor is a variable cost. These assumptions are often invalid in today's automated manufacturing environment, where employees would be essentially a fixed cost because you have more supervisory employees and everything's being done more in a mechanized manner. Now, in some cases, a favorable variance can be as bad as or even worse than an unfavorable variance. And then we could have an excessive emphasis on meeting the standards may overshadow other important objectives, such as maintaining or improving quality, on-time delivery, and customer satisfaction. And just meeting standards may not be sufficient. Continuous process improvement may be necessary in order to survive in a competitive environment. So now we'll go ahead and take a look at Appendix 10A, which is the predetermined overhead rates and the overhead analysis of the standard cost system. So we'll start looking at that either next in this video or in a subsequent video.